Hello everyone. In this video, we are going to discuss about classification of data structure. First of all, what is data structure? Data structure is a specialized format used for organizing, processing, retrieving and storing our data in an efficient way. Data structure usually classified into primitive and non-primitive data structures. The basic, fundamental or primary data types that are supported by any programming language is called primitive data structure. For example, basic data types like integer, character, real, boolean, etc. comes under primitive data structure. Data structures that are created with the help of primitive ones is called non-primitive data structure. Arrays, list, file, trees, graphs, etc. comes under non-primitive data structure. Non-primitive data structure can be further classified into linear and non-linear data structures. This chart clearly shows how data structure can be classified. Data structures where the elements are stored in sequential or consecutive memory locations is known as linear data structure. Some of the examples of linear data structure are arrays, linked list, stack and queue. Array contains a group of elements belong to same data type and the elements are stored in continuous memory locations. We can refer the array elements by using index or subscript. The array index usually starts with 0. Here is the syntax and example for declaring an array in C. We can give the data type followed by array name along with its size. The size of an array should be given within the square brackets. This is how the elements are stored in memory. Arrays have some limitations also, as the array size is fixed and elements occupy continuous locations in memory. Insertion and deletion may be little complicated here. Talking about linked list, the elements are referenced using nodes which form a sequential list. A node has two partitions where the element is stored in the left partition and the address of the next node is present in the right partition. This creates a link between the nodes. Next, we move on to stack and queue. Stack data structure follows last in first out structure so that the element which is added at the last is the first one to be deleted. Here, both insertion and deletion are done at same place, which is known as the top of the stack. Here, another variable is used which is called max that contains the number of elements a stack can hold. When the stack is empty, the value of top will be 0. When first element is inserted into the stack, top pointer gets incremented by 1 and moves to the next empty position. Stack supports three basic operations such as push, pop and peep. Push operation inserts a new element to the top of the stack. Pop removes the existing element from the top of the stack. Peep operation returns the value of topmost element in the stack without deleting it. Queue follows first in first out structure. Here, the element which is inserted first is the first one to be processed and taken out. In queue, insertion can be done at one end called rear and deletion occurs in the other end called front. At the beginning, when the queue is empty, both rear and front are 0. When one element is inserted into the queue, rear incremented by 1 and points to the next empty position. When deletion is done, the value of front will be incremented by 1. Next, we will see about nonlinear data structure. The data elements that does not follow any sequential or linear order while storing data are called nonlinear data structure. The best example for nonlinear data structure are trees and graph. A tree contains a collection of nodes that follows a hierarchical order. One of the nodes is designated as a root and the remaining are partitioned into disjoint sets where each set is a subtree of the root. This is an image of a binary tree that contains a root node and partitioned into less than or equal to two subtrees. And next, A graph contains a collection of vertices and edges that does not follow any sequential orders while storing. The vertices of a graph are also known as nodes. This is how data structure can be classified. Thank you.